Next question related to rotational equilibrium. The question is, there is one horizontal bar, horizontal rod is hinged at some position, something like this. Okay. To one end, I am keeping mass of 3m. 3m is the mass I am keeping at one end, and this length I am taking as some L by 3, and this length is 2L by 3. So then this end is attached to some pulley. Okay, to the pulley, so that pulley can rotate. Pulley is massless, you can take, okay, massless pulley, ideal pulley. Then there is a string. To the string, mass m is added, and other end we are adding some other mass, capital M. Okay, now we need to identify capital M value so that the bar remains horizontal. So find m value, find m to keep rod horizontal. That means ultimately we have to identify the balancing of forces or balancing of torques. Okay. Now see, here they won't be at rest. As this pulley is able to rotate, this can rotate, so one block can move up and down, but this should be at rest, and this has to be horizontal. Rod is horizontal, block M will be at rest, and these can move. Okay. So ultimately there will be some tension T, and T again, here also T will act and T will act. So these are the tension force acting. Then at this end, the total force acting is 2T, not these weights, because they are rotating. Pulley rotates and objects will go, objects under acceleration. So at one end 2T is the force acting. So if I am taking the rod like this is the hinge point. At one end force is 3 mg, at other end the force is 2T. Then how to find out the T value? Suppose it is coming down, this is going up. You can write down the equations. mg minus T is equal to m into A, T minus mg is equal to m into A, Newton laws of motion. So from all this, the tension value from Newton laws of motion is 2 m1 m2 by m1 plus m2 into g will be the tension acting in the Newton laws of motion. So this tension value I can apply now. 2 small m into capital M by small m plus capital M into g. This is the tension acting in the string. Now about this point, this is the point or axis of rotation I am taking. Then 3 mg will create clockwise torque, 2T will create anti-clockwise torques. So both has to cancel out. This length is L by 3 and this length is 2L by 3. Then if I am writing the torque equation, I can write down like this. 2T into force into, obviously this is the force line, perpendicular distance is 2L by 3. Perpendicular distance is 2L by 3 is equal to 3 mg into perpendicular distance is L by 3. For one thing, perpendicular distance is L by 3. For other thing, perpendicular distance is 2L by 3. So then L by 3 cancel out. Okay. So T is equal to, I'll get 3 mg by 4. So 3 mg by 4 is the tension value according to this. But already I know tension value by Newton laws of motion. Okay. So I am keeping the same. Now 2 small m capital M into g by small m plus capital M, that is the tension acting. Okay. Is equal to, in the string, is equal to 3 mg by 4. So small mg cancel out. Okay. Now cross multiply. Then 8 capital M is equal to 2 and 4. So it will become 8m is equal to 3 times of small m into small m plus capital M. Then 3m will be on this side, it will be 5m is equal to 3 small m. Then capital M value will become 3m by 5. So this is question directly balancing of our torques. But what is the idea to understand from this question is, see, not the force acting at this end is not equal to m plus m into g. The force value is 2T because they can accelerate, they can move here. So that is the importance of this question to be understood. Okay.